So the first problem that we're going to do today is going to be this limit problem. The first observation that you can make, if you're going to plug in like h is equal to 0 inside your function over here, then we're going to have a problem that we're going to have 0 over 0. So that's why you cannot just plug in. And another observation, if you will try to do any sort of algebra manipulation, that algebra manipulation is also not going to be successful because you have cube root under sign and you don't know any rules. But the idea is the following, that, as I said last time, whenever you see some sort of problem, you're going to have a cheat sheet. That problem usually is going to come from some section from the book. This involves limit, and you should recognize that this limit looks like the definition of derivative. And what is the definition of derivative? Following, that if you have f prime of x is going to be equal to limit when h goes to 0, and I'm going to have a fraction h on the bottom, f of x minus f of x. So in this case, what I'm going to have, if I'm going right now to pick my function to be equal to sine of x cubed, then what is going to tell me that I'm going to take my limit and rewrite it like this. So I'm going to have my f of x prime is equal to this, is equal to, I'm going to write down my limit and replace my function with actual sine function. And when I'm going to do this, how did I actually get that? You can observe if f of x is equal to sine x cubed, then f of x plus h is going to be equal to the sine. And here, what I'm going to do, I'm going to replace x, my input, with x plus h. And that x was the cube, so that's why. Okay, so that means that this limit is going to be equal, as you can see, the derivative of f. But if f is equal to sine x cubed, then that means that f prime of x is going to be equal to the derivative of sine, which is cosine. But then I'm going to use the chain rule and multiply derivatives of the inside. And derivative of the inside is going to be x cubed prime. And x cubed, by using the power rule, is going to be just equal to 3x squared. So if I'm going to write down my conclusion, then you should write down that the limit of that thing is equal to 3x squared cosine, and that is the final answer. One of the practice problems that we should do, we should try find this limit. And again, like if I will take my h is equal to 0, and just, this is the first intention of what you want to do, is just to take your limit, take h. I don't need to take a limit because I can just plug in my h. If I'm going to plug in my h, I will have 2x plus 0. Yes. On the bottom, I will have 0 times x plus 0. And you can see I will have 2x divided by 0. So that's the problem because we're dividing by 0. So one of the things that might suggest that you need to use a definition of derivative, that you have two variables inside your limit, and one of these variables is h. Remember that instead of h, you can have something else, which is t. So there is nothing unique and nothing. But when I know that I should try to use definition of derivative, I need to take this expression on the right and somehow try to simplify it. So the first thing what I can see that I have h on the bottom. So then what I will do, I will rewrite this expression in the form 1 over h times this, yes. But then I will remember the identity, which is the following, that if you have fraction, and on top you have a over b, and the bottom you have c over d, then that is going to be equal to the fraction ad over bc. Yeah, so this guy needs to be okay. So there's one. I'm going to. I'm just checking that the setup of the function is correct. Yeah, it's correct. Yeah, because okay, everything is good. So just remember like these identities, but we actually do not need to use it because when I rewrite this like this, what I can do, I will observe that on the bottom I have so first of all, here I'm going to use some other identity, not this one. I was trying to use this one, but I actually need to use this one. When you have a times 1 over b, yes, and that's exactly what we have here. But let me write down, so it's going to be identical to ours, is going to be 1 over b times a, where a in this case is my expression over here, and 1 over b is my exact. So I hope this makes sense. Then this expression a over b is going to be actually is equal to 1 over b times a is equal to a over b. So that means I can rewrite this expression. So what we did as a first step, as I said, we rewrote this expression that h is going to be on the bottom. So whenever you're going to get this problem, always try to just separate h that is on the bottom. Then the next, like, okay, so what do we do with the top part? And the top part, you can see that on the bottom you have x times x plus h. So that suggests me that I should rewrite this as x plus parenthesis x plus h. And what I'm going to do then, I'm going to split my fraction. I do not determine to multiply by 1 over h. I just take this h and rewrote that h is a separate fraction. Because if you will just multiply it out, this fraction and this fraction, that means the bottom parts are going to be multiplied. Okay, then I'm going to split the fraction on the top. So what I'm going to have x over x plus x plus h over x times x plus h. And here you can see that x plus h and x plus h are going to cancel out. And here, like x and x are going to cancel out. So what I'm actually going to obtain, I'm going to obtain 1 over x plus h is equal to 1 over x. But I will just, and 1 over x. And this is exactly, looks like right now, the expression over here. So that's why, what do we need to do? To find the original limit is the same as to find the limit of that expression. I'm going to pause here for a second. Yeah, I added this expression over here. So the rule that I use, how I move a fraction to the sum of those two fractions here, where c is my, and a is my x, and b is. Okay, for this one, we can see that my function is going to be then f of x is equal to 1 over. And that suggests that this is my f prime of x. So that means that my limit is going to be equal to f prime of x of fraction, which is going to be minus 1 divided by, and that's how we do the problem using when the original expression is not given like this. So recognize that you have separated and try to do some algebra to get this. Yeah, sorry, thank you for the catching mistake. For definition of the derivative, we must have minus, and that was just, let me put minus first here to fix. But then that suggests that my function should be like this one, h over h times x plus, because, then if you will have h here, we're going to have h here, So then to obtain x plus h, we're going to do the trick that we did in our previous discussion sessions. You're going to add x, and then you're going to subtract x. This, and when we're going to do this, then this thing is going to be with minus x. Yeah, and this is going to be plus x. So then this is exactly is going to be, yeah, so there was again like some mistake in my setup. So the idea overall is just whenever we see this expression, use the definition, but sometimes it might be hidden. So the idea is the same. Try to separate h and do some algebra. But because I came up with this problem on the spot, I did the wrong setup. So that's why I obtained plus instead of minus. But the idea overall is the same. Okay, so we discussed this as a limit problem. Like the good thing is actually to use problem to practice finding the derivative of a function using. I'm going to pick right now problem from one of the quizzes. And so what we're going to do? So here, let me put f. We're going to find the derivative of a function 1 over x squared using the definition of the limit, using the limit definition. So for that, I know that f prime of x is equal to limit when h goes to 0 of f of x plus h minus f of x over h. So here right now I need to replace, instead of f of x, my function, and I'm going to have 1 over x squared. And for this one on the left, I'm also going to have 1 over something squared, but there I'm going to replace x with x plus. That's going to be my first step. My second step, then I need to do some algebra. So what I'm going to do first, I'm going to find the common denominator on the top. So I can see that on the bottom for the first fraction, I have 1 over, I have x plus h squared, and here I have x squared. And I'm going to use the following rule that if I have, let's say, two fractions, 1 over a plus 1 over b, then I can rewrite this as b over ab, where I multiplied the first fraction by, and the second fraction is a over ab. And right now you can see that these two fractions have the same bottom part. So that means I can add them up. So I'm going to have b plus a over ab. So that's exactly what I'm going to do to simplify the function on the top. I'm going to multiply the first fraction by x squared, top and the bottom. And for the second fraction, I'm going to multiply top and the bottom by, and then what does it tell us? It tells us that we can take and subtract these two fractions. So I'm going to take this and we're going to collide these two fractions. So I will have x squared minus x plus h squared. Then I need to do again like some algebra when I'm going to FOIL, like expand the terms on the top. So what I'm going to have here, I'm going to expand squared. So I will have x squared plus 2xh plus h squared. Also remember the rule that I use, that we have the double fraction here. So that means that this part can be moved to the bottom to the h. And I'm going to rewrite this in the. So first, this guy is going to move to, and on the top, I'm going to be left with, okay. And then what else I'm going to do? I'm going to expand the minus sign. I will expand the minus. I'm going to expand the minus sign, so we'll have minus x squared minus 2xh and minus h squared. So from here, I can see that x squared and x squared are going to cancel out, and I can factor h. So what I'm going to obtain? I'm going to obtain then minus h times 2x plus h. And this is going to be in parentheses. And after this, I can observe that I can cancel out my h's, and then I can just find my limit directly by plugging in h is equal to 0. So when I'm going to plug in h is equal to 0, on the top I will have negative, and on the bottom I will have x squared times x squared. Yes, but if I'm going to simplify x on the top and the bottom, I will have exactly minus 2 divided by x cubed. And that is exactly the answer that we want. So the derivative of 1 over x squared using the limit definition indeed is a derivative that we're going to obtain if we were going to use the derivative table. So we want to grab the this rational function, and let me show you a couple of main ideas how to find the graph of any rational. First, remember that you have a rational function that looks like this. It's going to be f of x is equal to 1 over x. 1 over x. Then the graph of this rational function looks something like this, and that is my 1 over x. And I'm going just to show you the algorithm how to find the graph of any rational function. So first observe that this rational function have kind of two asymptotes. Y is equal to 0. So the first step that you should do, we should figure out, find the asymptote. To do that, what do we need to do? Okay, to do this, first we want to find vertical asymptotes. And remember, it's like bottom part doesn't equal to 0, or when it's equals to 0. Bottom part equals to 0, it's exactly when x minus 3 is equal to 0. So x is equal to 3 is the vertical asymptote of my function f of x. Next, to find horizontal asymptotes, what do you need to do? You need to look at the leading coefficients. And again, like if they are the same degree. In this case, the leading coefficients of degree 1. So in this case, I will have y, I will have that y is equal to 4 over 1, which is equal to 4. So that will suggest that if right now I'm going to sketch my Cartesian coordinate, x is equal to 3 is going to be somewhere here. It's going to be 1, 2, and that is going to be my vertical. And y is equal to 4 is going to be 1, is going to be somewhere here. And this is going to be exactly my. So I know that my graph is going to be either belong here and here, or my graph is going to be belong. So to find out, another thing that you can find the y-intercept and intercept. So for x1, what do you need to do? It intersects x-axis when y is equal to 0. But if y is equal to 0, then I will have 4x minus 6 is equal to 0. But that gives me that x is equal to 3 over 2, and that is going to be exactly my x. So that means my graph is going to intercept x exactly at one point over here. Okay, what about y-intercept? For y-intercept, I will have that x is equal to 0. But when then x is equal to 0, then my y is going to be equal to what? Is negative 6 over 3. Negative 6 over 3 is going to be equal to 2. So that suggests that my y-intercept is going to be at this point. So I can see that my rational function is going to look like this. It's going to intersect x and y-axis like this. And then I just will need to mirror this function over here. And you just put this, here's 3 over 2. And this one is 2. and we are done with graphing.